Hi guys, so we are now going to tackle arithmetic sequence, geometric sequence, and Fibonacci sequence. So before we start, let me introduce myself. I am Mikkaella Nadales from 11th Albireo, and here we go. And now let's start off arithmetic sequence. Arithmetic sequence is a sequence in which every term is made by adding a definite number called as a common difference to the preceding number. So, this is the formula of arithmetic sequence. A sub n is equals to a sub 1 plus the quantity of n minus 1 times the common difference. How to solve an arithmetic sequence? Let me give you an example. Given the example 1, 4, 7, 10, and 13. And let's say we are finding the 10th term. So we are now going to find the 10th term. 1, 4, 7, 10, and 13. And we are given that a sub 1 is equals to 1. The common difference is 3. And we are finding for the 10th term. All we have to do is to substitute. Since we are going to find the 10th term, we have to put here a sub 10 is equals to a sub 1 is 1, so we're going to put here 1 plus n is 10, so we have to put 10 minus 1, and the common difference is 3. You have to put it here. A sub 10 is equals to, remember the PEMDAS rule. We have to solve the 1 inside the parentheses. So 1 plus 10 minus 1 is 9 times 3. A sub 10 is equals to 1 plus 27. A sub 10 is equals to 28. So now we know that the 10th term is 28. Now let's move on. Geometric sequence. Geometric sequence is the sequence in which every term is created by multiplying a definite number called as a ratio with the preceding number. And now, this is the formula of geometric sequence. An is equals to a sub 1 times the ratio raised to n minus 1. How do we solve geometric sequence? I'll give you one example. Let's say we have 1, 2, 4, 8, 16, and so on and so forth. For example, we are finding the 9th term. How do we get that? Given the example earlier, we have 1, 2, 4, 8, and 16, and so on and so forth. A sub 1 is equals to 1, and we have the common ratio, which is 2, and we are going to find the 9th term. So, we have here the formula of geometric sequence. Now, all we have to do is to substitute. We have a sub 9 because we are going to find the 9th term is equals to 1 because that is the first term. Ratio is 2 raised to n is equals to 9 minus 1, and that's it. So we are going to find here a sub 9 is equals to 1 times 2 raised to 8 power. And according to PEMDAS, we have to solve the exponent. So we have here a sub 9 is equals to 1 And 2 to the 8th power is equals to 256. So we have a sub 9 is equals to 256. Now that we have solved the 9th term, and we all know that it was 256. Easy, right? So that was geometric sequence, and now let's move on to Fibonacci sequence. Fibonacci sequence is a sequence of number in which element is obtained by adding two preceding elements. The sequence starts with 0 and 1. So this is an example of Fibonacci sequence. 0, 1, 1, 2, 3, 5, and so on and so forth. As you can see, if we add 0 to 1, the next term is 1, and that is the sum of the first two terms. Let's, for example, have 1 plus 1, the second and the third term. If we add those two, we'll have 2, which is the fourth term. And that's how you get the Fibonacci sequence. Easy, right? And here are some facts about Fibonacci. Did you know that Fibonacci was not the first to know about the sequence? It was known in India hundreds of years before. Did you also know that we have Fibonacci Day? When is it? Well, it was on November 23rd, as it was written as 1123, which is part of the sequence 1, 1, 2, 3. Did you also know that the real name of Fibonacci was Leonardo Pisano Bugolo, and he lived between 1170 and 1250 in Italy? Well, Fibonacci was his nickname, which roughly means as the son of Bonacci. Now, do you have some ideas about Fibonacci and some origins of it? So that was it, arithmetic sequence, geometric sequence, and Fibonacci sequence. I hope you learned today, and goodbye!